All right, the first three sections of our book, we've talked about how wind and waves and water shape land. Today we're going to talk about in section 5.4 how glaciers, ice, forms land. And if you remember way in the beginning, I had said that's the one that people don't think about very often, about how ice can shape land. Well, this section we talk about some glaciers. Glaciers simply are just huge, big blocks of ice that move over land. Right now, our planet's pretty much it's covered about 10% with glaciers. At one point, they had covered 30% of all the present land that we have. There are two main types: alpine. Well, alpine glaciers form and flow down through mountains and valleys, and as they work their way through the valleys, they form a U-shaped valley because the glacier is so large that it just wears away the inner parts of the mountains there. They're also called valley glaciers. The other type of glacier is called the continental glacier. These guys could be called ice sheets. They're larger. They cover large areas. They can cover continent sizes. Now, as those glaciers move downhill, they push and they kind of act like a snowplow almost, and they plow up the land and the rocks all the way around in front of it, underneath it, to the sides of it. And as it's pushing down through the valley or across the continent, it pushes rock to the sides, kind of like if you ever shoveled sidewalk and you push the shovel and the snow just kind of builds up on the front of the blade and on both sides of it. That stuff that's left on the sides and on the front is called till. Now, till is made up of rock and soil and sediment and things that get pushed off to the side. It's also, that till is actually made up of rocks from other areas because the glacier has been pushing it for miles and miles and miles. And that's how scientists actually can tell if it's till rock or if it's just regular rock, is that if the rock in that pile is different from the area that it's in right now, it's been moved there by the glacier. Now, when you push that stuff along the sides, they build up these kind of mounds along the side of a glacier, and those are called moraines. With those moraines, once the glacier melts and retreats, it's not going to be there anymore, so it's just going to leave behind these moraines. And I think I have some pictures of it right over here. Yeah, right here. Here is one moraine, and here is the other moraine. And at one point, a glacier had come down through here and cleared out this valley. And you can still see there's a little bit of a river or a stream right here with left over from when the glacier went. Alpine glaciers and continental glaciers, examples of. Now, you can go to well, you can watch this, I guess. Let me move this so that we can actually view it. Now, what are glaciers? There's a, oh, lost it. There we go. They're just main big blocks of ice, and here's an example of an alpine glacier. You can see how it just looks like a river of ice flowing down. Now, where are they found? Usually around the North Pole and in the Arctic region, but they can be found in mountainous regions. The types, we talked about valley glaciers. We've talked about alpine glaciers, which are valley glaciers, continental glaciers, ice sheets, ice shelves, ice fields. These guys are all glaciers coming down through the mountains. Now, how do they form? You can read this, but basically what glacier forms is by it snowing more than it melts, and it gets compacted and gets compacted, and eventually the weight of the glacier becomes so large that gravity pulls it down. And that's kind of how it's explained right here if you want to read this. About how glaciers move. So when they do move, they can form these things called kettle lakes. Kettle Lakes, basically all they are is the glacier has worn away underneath the ground a bowl and dug out an area. And then as the glacier starts to retreat and melt, it fills in that hole, leaving behind a lake. Kettle Lakes are common here in Wisconsin and Minnesota and Michigan. Great Lakes were formed like this a long time ago, and we're going to watch a little video about that. But the weight of that ice was so enormous that it actually pressed the soil in about a kilometer, and that's how the Great Lakes end up forming. Here's a video about how the lakes formed.
It's covered with dead fish. Today, nearly 40 million people live in the Great Lakes region and depend upon its fresh water for drinking, washing, commerce, and recreation. But the freshwater seas still confront enormous challenges that call into question long-held assumptions about nature's role in our lives. The social, economic, and political stakes are high for the people in the region, the two nations they call home, and the entire world. From space, it's easy to see that Earth is mostly covered with water. Just 3% is fresh water, the essential resource for the nearly 7 billion people living on our planet. Most of Earth's fresh water is locked up in polar ice caps or is buried in underground aquifers. Less than 1% is accessible in lakes, rivers, and streams, and in more and more places, it's becoming increasingly scarce and valuable. The Great Lakes region is the ultimate exception. A freak of nature with a seemingly inexhaustible and invulnerable freshwater supply. Why is so much fresh water here? The story begins in outer space. The gravitational pulls of Jupiter and Venus distorted Earth's orbit around the Sun, launching an extended period of colder winters in which more snow fell than melted in summer, creating an ice age. Over the past 500,000 years, 6 ice ages occurred. The most recent began 70,000 years ago. A vast ice sheet expanded to the south, scraping away soft rock and sediment, and depositing enormous amounts of excavated material along the edges of the ice. Only hard rock substrate withstood the assault. The process reversed when the ice sheet began to melt, uncovering terrain that had been scraped clean and buried under tons of ice. The spores of lichens and moss took hold on the barren landscape, creating topsoil where plants and trees grew that eventually drew insects, birds, and animals. It took 5,500 years for the ice to melt to where Chicago is now. As it did, cascades of meltwater flowed to the sea, helping to carve the Mississippi River Valley. As the ice melted further, enormous basins excavated by the ice sheet were revealed. Over time, meltwater filled these excavations, forming glacial lakes covering thousands of square miles. The size and shape of these giant lakes changed as the ice sheet melted. Another factor also played a role. The enormous weight of the ice had compressed the ground beneath it. Once the ice melted, the terrain began rising, changing how water flowed in the region. The ice sheet melted from the Great Lakes region about 10,000 years ago, but climate change and the rebounding terrain continued to transform the lakes. Finally, 2,500 years ago, the Great Lakes became the natural wonders we know today, the foundations of a unique ecosystem where plants, animals, aquatic organisms, and people interact in an environment exceptionally rich in natural resources. Lake Superior is the largest freshwater lake in the world and the first in a series of enormous steps leading water down to the sea. It flows from the southeast corner of Lake Superior down the St. Mary's River into Lake Huron, 23 feet below. Lake Huron connects to Lake Michigan at the Straits of Mackinac, which separate the upper and lower peninsulas of Michigan. These two Great Lakes have the same surface elevation and are considered by many to be a single lake. From there, water flows down the St. Clair River to Lake St. Clair and the Detroit River, which feeds Lake Erie, the shallowest of the Great Lakes. Water flows north from Lake Erie into the Niagara River, where it cascades over the 200-foot cliffs of the American and Horseshoe Falls, known collectively as Niagara Falls. It then enters the fifth and final Great Lake, Ontario. From Lake Ontario, water flows into the St. Lawrence River for the final drop to the Gulf of St. Lawrence on the Atlantic Ocean.
So you can see how the Great Lakes here are just big giant kettle lakes left behind by the glaciers. And they do all kind of connect. And the reason why I showed you that video was, one, how they were formed, and two, how the water flows from here all the way through here to here out to the Atlantic Ocean. Here are some examples of a kettle lake. They're not as big, obviously, but they are kettle lakes. And labeling our lakes, Lake Michigan is the one right by us. Lake Superior, that's up in Minnesota. Lake Huron is right here. They said that these Lake Michigan and Lake Huron have the same elevation, so they're basically the same lake. Lake Erie right down here, and Lake Ontario right there. So all in all, how do glaciers form land? Well, they push through, they make moraines, they leave behind till, which is basically just like the glacier was a snowplow and it pushed the snow off to the side. Glaciers only form in cold areas, and they leave behind U-shaped valleys, and they can form kettle lakes. But that's it. So good luck on your work, and that's it.